genographic project also, all the applications were non-medical, okay, because we were getting data from all over the world. We have to respect their laws and rules and so on, and we stayed away from any functional part of the genome or any potential medical applications or medical ramifications it could have. And that was done even before FDA kind of came down on 23andMe and so on. So this is just to remind you that genographic we deal with non-medical applications. Okay. So, but I want to pose a problem, and I want to talk about how we use discrete algorithms or methods from discrete algorithms to pose problems and to answer the questions that we pose. So here is a simple question that we are going to pose, and I will take you very quickly through how to solve this problem. And I like it. It's called predicting the past. Some of you might know Andreas Dress is a mathematician, is a German mathematician. And when I was talking to him about this problem, he also works in phylogeny. He said, well, this is a problem about predicting the past. So essentially, predicting the past meaning where did we come from, and what are the routes that we took. But we are looking only at our genomic signature, only our genetic data. So in that context, I'm not going to address that question, but we'll get to that. I am going to pose a simple problem. On the left side, what you see, okay, on the left, what you're seeing is this structure, which is a tree, okay, and this tree you are getting from, if you want to analyze the non-recombining loci of your DNA. That is, you take the DNA of all the individuals here and focus only on that locus that does not recombine. So what are those loci? For example, the mitochondrial DNA. The mitochondrial DNA does not recombine. You inherit it only from your mother. Everybody here has inherited only from the mother, mother has inherited from her mother, and so on. It's a single line of descent is the non-recombining DNA. Or you could take the Y chromosome of all the men in this room, They have inherited it only from their father, and the father has inherited it only from his father, and so on. Okay, and it is a single line. So if I'm looking at only at mitochondrial DNA, or I'm looking only at Y chromosome DNA, so let's assume we are taking the Y chromosome. So we take the Y chromosomes of all the males here, and then try to build a common structure that will, of course, there are a lot of commonalities. There will be, we are all humans, we are 99.9% similar, so there will be commonalities, but you can build a structure out of it. The structure that you will build from the Y chromosomes that you collect from here is going to be a tree, which will look something like this, okay? And amazingly, it will also put populations together. So if you're Indians, if you're from Southeast Asia, you group into one. If you are Caucasians, Europeans, you get grouped into one, and so on. And these are signatures on our DNA. Okay, so these are SNP markers. This is a tree. Okay. But if I take a different locus, okay, which is your chromosome 1, or chromosome 2, or some other chromosome, your structure is no longer a tree because you inherit that locus either from your mother or from your father. Okay, so there is a mixing of parentage that is happening in that. So your particular locus, if you have two copies, if I take one of the haplotypes, take one copy, it could be your mom or your dad. Okay, supposing it is your mom, you go back to your mom. Her mom could be mom or dad. Okay, so it has gone through this combination. So the structure is no longer a tree. The structure, you will have these kind of networks. It becomes a complicated network. Okay. And that is the recombining DNA. Let's see what I have in the next slide. Okay. So my question I'm going to ask, it's a fairly precise question. That network, so the common structure here is a network. The common structure here is a tree. And since we all have a computer science kind of background, we understand that a network is much more complex than a tree, and here we are reconstructing a tree, and I'm asking about the question of reconstructing a network. So the question I'm going to pose is as follows, that since a network is going to be complex, assuming a sort of a simplified model, how much of the network can we really reconstruct? Okay? And the reference here is we make a simple assumption that assume that the tree that if you were to reconstruct was 100%. Of course, nothing is 100%, but let's assume that for the trees you were recovering was 100%. By this, what is the percentage that I can recover of the network if I use recombining DNA? Okay. So this is a basic question I'm going to pose, and the solution I'm going to offer to you, I will take you through a journey of how to solve this problem. Of course, this we also took over years to kind of address this question. It's a reasonable question because this question actually was posed by the geneticists that I was working with in the genographic project when we started talking and so on. It came up. He said, the first question was, can you even recover it? I said, I don't know, maybe we can. So then how much of it can you really recover? A good mathematical answer is always better because we have this inclination of math and other things. We want more precise answers than just shrugging and saying, oh, maybe you can, maybe you can't, and so on. So that is how the story started. So let me quickly take you through this one, and essentially we are trying to address, it is going to be a very simple model, but we will try to capture some of the essential inheritance models in that, and at the end of it I want to address how much of it can you recover in for the recombining process. This is always interesting at the beginning of the talk, it looks like I have a lot of time, so I will just go through that, is the origin of the subject population genomics. So I am talking now about population genomics and genetics. Okay? Of course, it goes back to Darwin and Mendel. And everybody knows Darwin. Sure, everybody knows Darwin, right? So it turns out that the theory that Darwin proposed, he was a genius, of course, undoubtedly he was a genius. The theory of heredity that Darwin proposed was actually wrong. Whereas Mendel had gotten it right. So what was wrong and what was right is that Mendel got it right between the inheritance across generations. In a local sense, he got it right. Darwin got it right in an evolutionary sense, how the species evolved and so on, but he got it wrong when it came to generation to generation. Okay, it was not totally wrong, but this was covered in a book called Brilliant Blunders by Genius. All the genius, all we know as geniuses have made some blunders. In fact, I will bring this thing up in our model later, very quickly to say the difference was that since at that time when Darwin was talking about origin of species and so on, we didn't know genes. We didn't know that there were discrete structures. We didn't know there were chromosomes or how we inherited. He had, the model he was proposing was a continuous model. Continuous model, roughly speaking, very roughly speaking, it means that the offspring, the phenotype, or what the offspring looks like in some sense, of two parents is a mixture of what you have. Roughly speaking, if there is, shall I say, without any racial undertones, I'm not trying to have racial undertones here. If there is a black parent and there is a white parent, then the offspring is a mixture and gray individual. Okay, so roughly speaking, this is what we thought because the units were not known. Whereas Mendelian, because he was dealing with peas and he knew exactly how the phenotypes of these peas were being inherited. I'm assuming people are kind of know the stories of this thing. He knew that it is not a mixture, it is a discrete model. It's either from the mother or the father, you mix it around and so on. Okay? And so his model was actually discrete. So Darwin's was a continuous model, Mendel was a discrete model. So that is the model of inheritance. This is an interesting story, so I spent a lot of time just telling you what this story is. And I will now, I am sure there are no population geneticists in the crowd, so I will summarize 100 or 150 years of the work in one slide. Essentially, I'll just try to take the features that we deal with. Population genetics, if you look at the definition in Wiki and other places, it says it deals with the statistical analysis of the inheritance and prevalence of genes in populations. And Wright, Fisher, and Haldane are the fathers of this. And I also realized that Haldane was in Bhubaneswar, right? There was a statistical institute in Bhubaneswar. I was reading a book, I planned to get the pages of it from here, and there were letters he was writing, and they are in some institute in Bhubaneswar. And so Bhubaneswar and Calcutta were actually hubs of statistical institute in the early part of last century. And I should have dug a little more, spent a little more time, and it was amazing that in this book, he has all these letters that he writes, and the address is Bhubaneswar in some institutes here. So in statistics, you have the Statistical Institute in Calcutta and so on. Fisher and other people have spent a lot of time in India, and we did have great statisticians that came out even from India. Mahalanobis, we know the Mahalanobis distance, and also there's another model that we do. Kozambi was a mathematician whose models we are still using of inheritance and so on. So this was a hub for Calcutta, Bhubaneswar kind of was a hub for a lot of statistics and all. But they were essentially statisticians at that time. They were quantitative genetics. And the next thing I want to go into is the neutral theory that came around in 1968 to 80, an important theory. This came about by Mutu Kimura, Japanese. And what it says is that until then there was a belief that every mutation and other things that we are inheriting is due to selection. Okay? So everything was selection oriented. Whereas he said that most of the things that we actually inherit are just accidental. Not accidental, well, it's neutral. It doesn't matter, so it's not selection. So it is an important criterion, so we can actually use our random models and so on, which are not taking selection into account. So important idea, but you can see that it's around 68 and 80s that came along. The other third link that I'm going to use is Kingman's coalescence. Kingman's coalescence is a retrospective coalescent theory. Let me just briefly let me see if I can, in 2 or 3 sentences, say what it is. He actually studied reconstructing the history of the different SNPs that you see backwards, okay? Kind of predicting the past that we did. And he has this very beautiful theory called coalescent theory. I in fact say it's like a painting or a poetry. That's how beautiful the theory is. So it essentially means that you look at the SNP markers of the extant units meaning the individuals of today, and then you build a coalescent theory, which is like he was building a tree, which is when two nodes meet, what we know as a node and the vertices, that was called coalescence and so on. And I actually call his coalescence as explicitizing the tree, because we come from computer science, we know trees, we know graphs, and in my mind, this is how the trees explicitize from the genetic markers that we make. And then, of course, early part of the century, from 1990s onwards, genomes started getting sequenced, and then you have many, of course you had the Human Genome Project, so it got completed around 2000 at a large price, like $1 billion and so on. And then what we noticed is that the humans have more differences than we expected. Okay, so it was not enough to just have one reference genome. There are so many more differences that there are a lot of these other things, like you have to study the genomic variations within the species or within humans, and many other projects came up. And population genomics and genetics is essentially, we went from population genetics to population genomics because large genomes became available. I always put this as a joke on the other side, which is the 1,000 Bull Genomes Project, and I say that where there is money, there will be genomes, because this is the beef industry in the US. They want to sequence the bulls, although the bulls are very close to each other, but there is money there, and there is likely to be other ramifications. So there is a 1,000 Bull Genome Project. That means you are going to provide fund for sequencing 1,000 bulls so that you can understand the variations. I think, so this is the context of everything. Now I'm quickly coming back to the modeling that we want to do, and I'll tell you about the coalescent theory and so on. So let me quickly define the model. So what you're looking at here is these rows that you are seeing. this is a generation, okay, and the circles that you are seeing are individuals in that generation, and the lines that you are seeing is the transmission of the genetic material from the previous generation. So this individual got his or her genetic material from this individual of the previous generation, and this is the generation before that, and so on. So if I'm going to track in the ideal case, if I take these 4 individuals from here and I track their genetic material, how they inherited, this is what the picture looks like if we have all the information. And since if there are chains, you really wouldn't know, so this is a tree that we will get. Okay? That I'll call the phylogeny, and this, roughly speaking, would have been due to the coalescence by the Kingman's model also, which I had said before. And this can actually go on forever. In this model, this can go on forever. So what we do is, what is done in the community is that you identify what is called the least common ancestor, LCA, of all these 3 individuals, and you terminated them, because it's a big chain that goes on forever. And that is an important criterion that you use, because that takes this potentially infinite structure and it makes it finite. And it is that after that it doesn't matter, that's the structure that you talked about, and it is called MRCA in population genetics, most recent common ancestor. And that's the most recent common ancestor of the 4 individuals selected. So if it is a population, so you're representing populations, so you can have representatives from the populations, and you get the most recent common ancestor. So here, of course, what I did, some of you noticed, some of you did, is that I showed that the genetic material was being inherited only from a single individual. Okay, it came from a single parent. Okay, so and that is true for unilinear transmission of genetic material. So it is a single parent hormone. But like I said, we want to take recombining loci. So when we want to take recombining loci, we want to take multiple parents or nodes, and the structure gets more complicated. So you can have another edge going from here, and then it goes to a loop. Right? So the difference between the tree and the GMRCF, the main difference is that for one individual, in this model, you have just one parent, and here in this model, you will have at most 2 parents. So you can have 1 or 2. And so that is the only change in the structure that we allow, and the resulting network can be very complicated. So on the left, what you are seeing is the phylogeny constructed out of real data, real mitochondrial data of African samples, and this is the structure that you get. On the right, what you are seeing is a toy example of a very small segment of a few individuals, and you can see how complicated that whole structure looks. Okay, these are the simulation studies. So that is why the question that we asked earlier on, that how much of this tree or how much of this network can we really reconstruct. So I have used the term here ARG, which probably was introduced in the previous slide, but I didn't talk about it. So ARG stands for Ancestral Recombinations Graph. That is the same thing as a network. This is a term coined by population geneticists. And like I said, this is only local difference in the structure that you allow, and the resulting structure is complicated. This is just to remind you, this is a question that we are trying to address. So what I'm going to do is I'm going to use a random graph framework where we'll start from scratch, we'll start from the beginning, and what we do is, which I've already told you before, is that the model I'm going to assume is that we take these extant units, and so we have the blue nodes, which are the males, the hollow nodes, which are the red hollow nodes, are the mothers, the females in the population. So that is a Wright-Fisher population model that we use coming from population geneticists. The way this random graph is generated is as follows. You take an individual, you randomly pick one father and randomly pick one mother. Okay? And at every generation we do the same thing. So this is a complete structure. So at every generation you just pick randomly one father and one mother, and you get this structure. This is a random structure because you generate it again, your structure will differ. And this is as late as January 30th. Even today I saw there was an article, New York Times opinion op-ed on this, but I didn't have time to pull that out, but it's similarly summarizing these things. Obama to unveil research initiative to develop tailored medical treatments, which is precision medicine. And of course, there is always a warning that this moonshot medicine will let us down. People in the field know that, because it is similar to when the genome was sequenced 15 years ago. At that time, everybody said that we'll understand everything. We'll understand how genes work. We'll understand the diseases. We will, there'll be larger help from that. But it has been slow. We have not understood it to the extent that we did. And there's a similar thing happening here. This medicine is being called the moonshot medicine, and it's going to let us down. So there is warning in the media, and scientists don't need warning. They probably already know that there is. But funding, you don't refuse funding. So if Obama is going to fund these things, it's a good thing. NIH is going to get probably $130 million or something, and so on. So this is always a good starting point, except that what you expect out of it may not match. So this is just a word of caution. That is all that we have put in. But Obama has announced $250 million precision medicine investment for NIH, FDA. I'm talking about USA, but it actually means that funding is always good because your knowledge improves in that area. So this is my little spiel for what it is and why we need it. I will probably not get into the details of that. This is some work we did on microbiome sample. So microbiomes meaning the bacteria and other things in your gut, or the one here is on fecal samples. The result we have on fecal samples. And how is it related to precision medicine here is because you are looking at the gut samples of individuals and you are trying to understand what you can say from the samples from those individuals. We look at RNA-seq data. RNA-seq data, for people who are not familiar, it simply means that it is not looking just as the genes that exist, but what is being expressed. What are the genes or the proteins that is being expressed? We would look at that data and try to guess just from the microbiome samples what is the phenotype. Phenotype meaning is the person healthy or diseased for particular diseases. So I will just quickly sort of go over this. In fact, this is a paper that is there in your proceedings, so you're encouraged to take a look at it and you'll get the details from that. And one of the challenges, of course, here is that this is heavily multidimensional data. So you will have like 500 different kinds of microbes and so on and other things. So the visualization also becomes an important factor. So what we are doing is we are giving some. That was my last slide. So I was just, so there is also a visualization that is done, and this visualization is based on TDA, which is a hot thing now. Topological data analysis comes from mathematics, field of mathematics, and we are using TDA to do the visualization of this as a test case. And before I stop, I think I should also mention that in IBM, some of my group is also involved in what's called the WGA Watson Genomics Analytics. So that is, IBM is actually working on providing precision medicine in the area of cancer. So glioblastoma is what we are looking at. Although that part of work is something that I did not cover in my talk. So I will stop here. A lot of people need to be thanked. I'm sure the list is not complete. Many of my co-authors here, and thank you for your time, and thank you for your patience.
Whatever you have done is mostly based on tracing through the past, the algorithms and all of that. So once you have done that, once you have reached at the least common ancestor and you have done your algorithms and everything, will this research be useful in projecting that to the future in some way? I mean,
right.
can you predict where people from Orissa will migrate to, or maybe how after 5 generations how it will look like?
No,
something.
Yeah, right. It is, actually, Where they will migrate to is probably a harder
I
question.
just wanted to
Yes.
give you an example.
Yeah, but they do such kind of projection like on speciation. That means these species were formed. What are the new species we can come up, and that is done, but not at this level. And the modeling, another thing that we are doing is retrospective. So we take the extent units and say how is it best explained the variation that we are seeing right now. So that's the thing. We haven't looked into projections.
My question is just extending that to the future generation.
Yes. We haven't looked
Trying to
into it.
find out some conclusion that yes, the height of people in this area is likely to increase in next few generations. Something like that.
Right.
And then which could be very interesting also.
Would be interesting, would be a nice thing, but we'll have to take a lot of other factors into account. Economy and so on and other things. Right now the world is becoming very small and people are everywhere and they're mixing up and so on. So it's an interesting question.
Good morning to everybody. First of all, I would like to thank Professor Manas Patra and Peter Shamuhanti and Professor Rasha also for the kind invitation and for our history of collaboration, and I'm very happy to be here today. So, although my background is computer science, I have not been working in core computer science for the last 10 years, and I've been working in electronic governance, which is an application domain. So my talk today is not about graph theories, all what we enjoy very much, but it's about applications of computer science solutions, applications of the ICT tools that we can deploy. And in particular, I will talk about electronic participation. So the aim of the talk is to introduce the concept of electronic participation, to review real-life case studies that are being developed, are being implemented in different countries around the world. And from these case studies, we did an analysis and we proposed an electronic participation framework. And I would like to also explain how this framework can be applied in practice to develop new e-participation initiatives. So following the aim, the talk is structured in 5 sections. First, I will introduce the concept of electronic participation. Then I will present the case studies that we surveyed. Third, I will explain the framework. Later, I will explain how this framework can be applied to support e-participation initiatives. And finally, I will conclude the talk. So let's start with understanding what means citizen participation. And before talking about participation, I will talk about engagement. What is citizen engagement? So it refers to public involvement in determining how the society can steer itself, how the society can make decisions on major public policies that affect citizens' lives, and how governments can deliver programs that can really benefit citizens. And when we talk about citizen engagement, we are talking about a deliberative process. In this process, we are engaging stakeholders who are representing the citizens' communities, the different communities. And during the process, we allow citizens to learn, also to express their view, and to influence the way government makes decisions. So, when we try to understand what are the ultimate goals of citizen participation, this is a nice graph that shows what are the ultimate benefits. First of all, we see where we can engage citizens through the different stages of public policy. When governments define public policies, they have a life cycle started from agenda setting, where the issues that needs to be defined, discussed, and where we need policies are defined. Then we have the policy formulation, we make decisions, policy implementation through different government programs and projects, and finally we evaluate how the policy is being implemented. So we can engage citizens through all the different life cycle stages of the policy process. When we engage citizens, the goals that government pursue are related for the citizens to learn, because they would like to have a more educated public. We want to have a more educated society. because we want citizens to express their views, because we would like the government decisions to be shaped by the voice, by the views, by the concerns of the citizens. And we also like citizens to influence decisions for governments to make better decision making. Finally, the governance benefits that we see during this process is that we can reduce the power of special interest. You know that governments many times are influenced by lobbyist groups, that they are very powerful and they have they can make influence in the decision making. So if we allow citizens to raise their voice, we can somehow reduce this type of not desired behaviors in the society. We can also have policies that can hold over time because better represent the interest of the society. We have constituencies committed to the outcomes of the government programs, and we also have increased trust in governance because citizens will trust more the government actions and programs. So, we would like to make a difference also between citizen engagement and citizen participation because the literature recalls some important difference. In particular, when we talk about citizen engagement, we are assuming that the citizens, people want to have a say, they want to have a say in the decisions that affect their lives and are interested in improving their well-being through their own actions. On the other side, when we talk about citizen participation, we assume that people's voices and concerns are heard and are considered by the government authorities. So examples of citizen engagement, for instance, is citizens voting in a referendum or citizens consulting in urban planning on some specific government policies, like for instance education, health, etc. In the case of citizen participation, for instance, examples are when citizens participate in social movements, when citizens write to their representatives, taking their own initiatives. So the difference in processes is, if we recall the examples of citizen engagement, there was something provided by the government, because if the citizens goes to vote, the government needs to establish the procedures and give the tools. So we said that processes are promoted and conducted by government, that formal structures need to be institutionalized, for instance, policies determined by governments, systems, principles, and rules of procedures. While in citizen participation, the actions can be taken by initiative of the citizens, and there are no formal structures. In general, we say also that for citizen engagements, the governments encourage specific actions from citizens to deliberate and assess and propose improvements to the governments, while in citizen participations, the citizens deliberate, assess, and propose among themselves and also with government authorities. So, if we see the evolution in citizen participation, initially the process was focusing on trying to engage citizens in participate and involve citizens in government processes and in government decision making. While nowadays the focus is shifting to engage citizens and also empower citizens. So there is a fundamental shift going through information exchange, where governments were providing information and also citizens were expressing their views, to a more a different process that is now information processing, in which through participation the citizens can process information, can enrich their capacity, and can get more involved in the decisions that affect really their lives. So if we see this evolution, we can see that there is also an alignment between the 5 different stages that are defined by the International Association for Public Participation, in which they talk about 5 phases, starting from inform, going to consult, involving citizens, collaboration with citizens, and empowerment. And if we look at the different goals of each of these stages, starting with informing, in order, if we would like citizens to be engaged, to participate in government decision making, we need to inform them. They need information, they need to talk, to know what are the issues being discussed in government. So we start with inform. Then we need to consult because the citizens need to provide feedback and they need to provide inputs to the analysis. Needs to be involved because they need to work together with public authorities to ensure that their aspirations, that their concerns are taken into account. They need to collaborate, to partner with the public in each aspect of the decision making, and they also need to empower to make sure that the final authority of the decision making is defined, is in hands of the public. So, I was talking about citizen engagement, I was talking about citizen participation, and now I would like to put the ICT on top of these concepts, and then we can talk in general about electronic participation or e-participation. So e-participation is trying to foster, are all the initiatives that foster active participation of the civil society on policy development and in government decision and actions, seeking such participation through electronic channels, through the use of ICT. So in general, when we talk about e-participation, we can talk about 3 different levels of engagement. One is e-informing, so we are using ICT, we are using electronic channels in order to provide information to the citizens, to show them, for instance, the availability of elected officials, of government structures, of policies, programs, to inform the citizen. We can talk about e-consultation, so the places online where the discussions can take place, where citizens can express their voice on real time, also for instance where they can receive broadcasting of parliament sessions. And the final is e-decision making, where the tools or the initiatives give the possibilities to citizens to provide the inputs in the government decision making processes. So if we look at the 5 stages we were talking about, when we talk about inform, this is the e-information stage of e-participation. E-consultation involves consult and involve, and e-decision making involves collaboration and empower. One more aspect about the use of ICT for citizen participation is that we need to consider mainly three issues. One is the timing, so in which part of the public policy life cycle we are going to engage citizens. Although it's possible to engage citizens in the 5 stages, agenda setting, policy formulation, decision making, policy implementation and monitoring, the experiences shows that usually citizens are mostly involved in agenda setting. Second is tailoring, because we need to tailor, we need to customize the specific e-participation initiatives to the different levels of governments that will be engaging citizens. If it is a national government or if it is a local government, for example, and there are different cases. For instance, the national government may like to involve citizens in the decision of a law, in the discussions of a law, while the local government may like to engage citizens in urban planning, for instance, where deciding where to put a building or how the building should look. And also, the third issue is about integration, because one important issue is we already have a lot of divides in our society, and we would not like to add one more divide at the time of affecting government decisions. So we need to make sure that we need to integrate online participation through other traditional channels. Finally, I would like to talk about concepts about the different participation areas, because there are different problems in which we would like to engage citizens or areas. So, for example, we would like to talk about information provisioning. So, the use of ICT to structure, represent, and manage information in different participation contexts. Another participation area is community building, all the type of ICT tools that we can provide to build communities and to allow communities to discuss topics of their interest. Consultations to contribute, to allow citizens to contribute with their opinions and on specific issues. Campaigning to support collective actions in protesting, in lobbying, in petitioning, and so on, like electioneering, deliberation, discourse, mediation, spatial planning, polling, and voting. So after presenting the concepts of e-participation, I would like to present case studies of around the world. And we did a survey in which we defined a data collection instrument, we documented 20 case studies, and finally we have the analysis and some summary. So I would like to briefly present these three main parts. This is a snapshot of the data collection instrument that we defined, and we mainly defined 5 dimensions that we would like to assess from the initiatives: who was running the initiative, where the initiative was conducted, why the initiative was undertaken, what was the initiative about, and how the initiative was implemented. These are the 20 case studies that we analyzed from different countries. We try as much as possible to have a whole coverage in terms of geographic distribution of the countries and also levels of development. And I will not present here the 20 case study, but I will just select those that says yes in the column to present. So the first initiative is Gabinete Digital. This was conducted in the state of Rio Grande do Sul in Brazil. The initiative was started in 2011 and mainly is an online portal that provides a channel for citizens to participate. Within this portal, there are several initiatives, like for instance the governor response. So citizens can ask questions to the governor, and the most voted questions are personally answered by the governor. The second, Governor Ask. So the governor asks citizens to provide inputs on specific issues that are of relevant to the state, and send their contributions through the web. When the citizens send their contribution, other citizens vote about this contribution. And those contributions that the authors manage to get more than 50 votes are invited for the government, has a meeting in person with the governor for him or her to explain the solution. Governor listens, so public hearings are transmitted through internet, and a collaborative agenda where the governors move around in different cities with the ministers to talk about specific needs. And here is the example of the portal. And there is a very nice balance of the activities of the last 4 years. The second example is Uchaguzi, Uganda. This was initiated mainly by NGOs. The initiative was conducted during the elections in Uganda in 2011. Was implemented to monitor national elections. The platform was based on Ushahidi. Do you know about Ushahidi? I think it was used here in India in the last elections. Ushahidi is an open source tool that was developed in Kenya in 2008 by 4 programmers during a weekend, because they wanted to have a way to make public the different conflicts that were taken after the elections in Kenya. And this was very useful. It had a high impact in the society, and then it was released as open source, and it has been used in different countries in the world. And there was a reference that it has been used in India in the past elections. Okay.
What is it?
Yes?
It looks an exit poll, or what does it do?
It's an app, it's a solution, and it's a platform, of course, that enables citizens to report with their mobile devices in different type of incidents. So, for instance, if they go to a voting place and there is some failure in the procedure, or if there is something wrong happening during the process. But it has been used with different type of purposes. Although it was created to monitor electionary processes, it is used also, for instance, for citizens to declare different type of problems in the urban setting. For instance, if there is a traffic light that is not working, or if there is a waste that has not been picked, etc. Okay? It has been also used for in developing countries, and I'm talking about here different cases of citizen participation. Yes, it has been used in different countries for women to report violence. So women, if they feel some kind of abuse or some uncomfortable situations, they can report, and then they give them in the map. You can see what are the neighborhoods where it's not safe, for example. Okay. So in the case of Uganda, the platform was used to provide for engaging citizens in protecting the democracy, enables reporting through social media, web forms, SMS, different kinds of incidents, and they also can subscribe to receive alerts in their mobile phones to see what kind of problems they were having. And this is the kind of solution. In the map, you can see, for instance, voter issues, security issues, police actions, etc. The third one is from the US. The initiative was started in 2011 by Obama administration, and the idea is that the citizens write a short headline about describing a petition to the government. The petition can be categorized in different topics. The important thing, and not to have a spread of the different concerns of citizens, is that citizens are encouraged to look if there is some petition similar to the concern they have, and if such, they can join a previous petition. And after completing the petition itself, the citizens is responsible to promote this petition, because he needs to get 150 signatures in order for the petition to be accepted in the public searches after he submitted, and then he or she has 30 days in order to get 100,000 signatures. And if they get 100,000 signatures in 30 days, then the petition is considered to be worthwhile to be submitted to the administration and ensures an answer. So this is the portal, and you can see more information there. Coho Wallet, and this is another example I bring because in many countries, one of the problems of democracy is that many citizens do not know what is happening in the parliament. For instance, we vote members of the parliament, and then members of the parliaments do not go to the sessions, or they vote against what they were claiming in the political campaign, and so on. So this solution tries to address this problem. It was created in Czech Republic in 2007, launched by an independent organization, and mainly consists of an online portal that organizes parliament-related information more clearly, gives the user the opportunity to take a quiz to assess what are the concerns or what are the most preferred political choices of the citizens, to match his preferences with the representatives in the parliament who are more aligned with his thoughts. And political parties are also requested to inform about the future plans, and they give information about who are the parliaments, the members of the parliament more active, what type of decisions they are making, etc. So thank you very much. This was my talk.
Established methodologies which can be referred, because of late we were also trying to work on similar situations. So on that issues, are there any kind of established frameworks which can be taken as a reference?
It depends, as I mentioned on the participation areas, there are completely different kind of problems and completely different type of solution and architecture that you will use. If you are talking about, for instance, voting, this is one type of problems, and there will be some solutions there. If you are talking about urban planning, they are completely different. If you are talking about reporting issues, okay? So, for instance, an example, for reporting issues, Ushahidi will be an ideal platform, okay? But it depends on the participation area in which you are targeting, then I can discuss more the type of platforms or the type of architecture more suitable.